This is part 2 of Module 6, Lesson 6. You are looking at the back page of your problem set. And it says template up there. And it's a nice big coordinate system. So let's start off by labeling our axes. It's just a good habit to get into. Then, remember what we were doing in the previous lesson where we were trying to figure out before we started plotting points or doing anything, we had to figure out how our whole numbers were broken up. What was in between them? So it looks like there's 1, 2, 3, 4. So this is broken up into fourths. So 1, 2 would be a half. 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 All right, let's keep going. Let's check it up here. 1, 2, 3, 4. So 1, 2 would be a half. 1, 2 would be a half. 1, 2 would be a half. And 1, 2 would be a half. So this is 3.5. This is 2.5. This is 1.5. This is half, this is 1.5, this is 2.5, this is 3.5, right? Okay, so now that we have our coordinate system, our coordinate plane labeled, now let's start plotting some points and asking some questions, because remember, our objective was to investigate patterns in vertical and horizontal lines and interpret points on the plane as distances from the axes. All right, so if I plot a point at, I'm going to go 2.5. And I'm going to call this point A. So let's think about this for a second. What do these coordinates? So let's go ahead and identify the coordinates. The coordinate is on the x-axis, because we always start with the x-axis, is 2.5. And the y-axis is 1 1/4. So when we write this in, that's how we write our coordinate pair. Now, what do these coordinates tell us? What do these coordinates tell us? Well, first of all, they tell us directions, really. They tell us where to go first and where to go second to find a particular point in a coordinate plane. They tell you how far over on the x-axis you have to travel from 0, and then how far up parallel to the y you have to go to find the point. The first one tells us how far over, and the second one tells us how far up. So I would like to describe the shortest distance to point A from the x-axis. So I want to find the shortest way to describe. So I'm going to say that again. I would like to describe the shortest distance to A from the x-axis. So how do I find the shortest distance to A from the x-axis? How do you do it? Well, you just go straight up from the x-axis and count the units. It's 1 1/4 straight up from the line, correct? The y-coordinate tells you how far from the x-axis you have to go up. It's like the horizontal lines we did yesterday. The y-coordinate, or on Friday, the y-coordinate tells us how far the point is from the x-axis. So go the same distance as the y-axis. So the 2.5 by 1 1/4, that is how I give directions. That's how I describe the shortest distance to A from the x-axis. Now, if I want to describe the shortest distance to A from the y-axis, how far is A from the y-axis along a perpendicular line to y? So it's the same thing. Just go straight over from the y-axis. It is 2.5 units from the y in a straight line that's parallel to the x. So the x coordinate tells the distance from y. It is 2.5 units in a perpendicular line from y. So what is the shortest distance to A from the x-axis? The shortest distance from the y, it is from the x-axis is 1 1/4 units. The shortest distance to A is 1 1/4 units from the x-axis. What is the shortest distance to A from the y-axis? It's 2.5 units from the x. Sorry, the shortest distance to A from the y-axis. So moving from the y-axis is 2.5 units. Moving away from the x-axis, it is 1 1/4. So, is it important in recording the coordinates in the correct order? Yes, it is. If it's switched, then you're going to end up at a completely different place. You would end up all the way up here if you switch the coordinates. So, what do you notice about the distances from each of the axes? What do you notice about these distances from each of the axes? Well, the x-coordinate tells the shortest distance to the point from the y, and the y-coordinate tells us the shortest distance from the x. So that's that relationship part that was part of our objective today, is investigate the patterns in vertical and horizontal lines and interpret the points on the plane as distances from the axes. All right. We're moving on. So now this is where you're going to need your straight edge. You are going to draw a line so that it has a point A in it and is perpendicular to the x-axis. So I'm going to draw a line that is perpendicular to the x-axis and contains A. So I'm going to continue it all the way up. And I'm going to call this line L. All right. Now, I want you to give the coordinates for another point on line L. Now, if we know that this point is 2.5 by 1 1/4, I want you to give one more coordinate that is 1.5 units farther up from the x-axis than A, and you're going to label it B. So 1.5 units larger than point A. Where do you end up? I want you to do that right now and label it. Okay, did you end up here and label it B? So you were to do 1.5. So 1.5 plus 1.5. So, sorry, yeah. This is 1.25 plus 1.5. So I'm going to just double it and go from 1.25 to 2.25. And then I have to add a half. And each one of these is a quarter. So a quarter plus a quarter is a half. So your B ends up at 2.75. So your coordinates are 2.5 by 2.75. Okay. So did you see the way I used my fingers I just added. Now, what if I go up 1/4 from A? So if I go up 1/4 from A and down 1/4 from B. So I'm here and now I'm here. So I want you to give the coordinates for the point on L that is halfway between A and B. So what is the coordinate halfway between A and B? Go ahead and do that, label it, and come back. Did you get C and label it C? Did you get 2.5 and 2? So if you can basically count. You could go up 1, 2, 3, 4, 5, 6. What's half of 6? 3. So 1, 2, 3. Or you could subtract 2.5 from 1.25. So you should have 2.5 and 2. Those should be your new coordinates. Okay, moving on. So I counted up from A and there were 6/4. There were 6/4 until I got to B. Half of 6/4 is 3/4. So the location of the point would have to have a y coordinate that is 3/4 more than A, which would be 2. So the length of AB, so the length from point A to point B is 1.5. So I could find half of 1.5, which is 3/4, and that would help me locate the point. So the distance from here is 1.5. And half of that is 3/4. Since the point on L, line L, we know that the x coordinate is going to be 2.5 all the time. Halfway between the y coordinate is 2, so the location is 2.5 by 2. And we have that down. Okay, now I want you to draw another line and I want you to label that line M. But it needs to be perpendicular to it has to be perpendicular to the x-axis, and it's going to be parallel to line L and a half a unit from the x-axis. So what is that going to look like? So, we are going to draw another line that is going to be line M. Line M, it's going to be perpendicular to line L and a half a unit from the x-axis. So let's find a half a unit. Okay, here's half. Here's a quarter, and a quarter is a half. So we're going to draw, this is line M. All right. So you are going to plot a point D where the lines M and N intersect. So what is that point where line N and M intersect? And we're going to label that point D. So D ends up being 2.5 on the X and half on the Y. So our coordinates look like 2.5 by 1/2. All right, next part, we are going to plot a point E. On the line M, that is 3/4 of a unit. So 3/4, remember, here's a quarter, here's a quarter, here's a quarter. So 3/4 unit from the y-axis, 3/4 of a unit from the y-axis, then record the coordinates of E on the chart. Go ahead and do that and check your work. All right, is this where you plotted your point E? I went back and I just labeled my points because many times that is a requirement. It's just a habit to get into. Then finally, our final letter that our final point is going to be point F. On line M, that is 3/4 of a unit farther from the y-axis than E. So 3/4 farther from the y-axis than E. So if this is 1/4, 2/4, now try it, label it F, and come back and check. All right, so did you count 3/4 over? Label it F. Then that is your coordinate pair for that point. And then I went down and filled in my chart. Were you able to do that successfully? Excellent. So now we are going to move on to identify regions of the plane created by intersecting lines. So I'm going to move my finger along the plane. Say stop when I get to a location that is 1.5 units from the y-axis. 1.5 units from the y-axis. Stop, right? All right. So I'm here. Is every x coordinate to the left of this line, to the left of this line, to the left of 1.5, is it going to be greater than or less than 1.5? So it's going to be less than 1.5. And every x coordinate to the right of this line is going to be what? Greater than 1.5. So let's draw a line and label it N to go through line F and be perpendicular. Let's label that N. Okay. So from here, we're going to use our red pencil or crayon or something like red to shade the part of the plane that we can see that is more than 1.5 units from the x-axis. So 1.5 units from the x-axis, right? So all of this is going to be 1.5 units from the x-axis. Okay. Go ahead and do that. You don't have to spend too much time coloring. Okay, so all of the red is 1.5 units. Everything beyond 1.5 is 1.5 units farther than the y-axis. Now, everything less than 1.5 units from the y-axis, we're going to label. I'm going to color it in blue or something like that. 2 different colors. Okay. Now, finish that up. Okay, now take your pencil. So because now we're gonna, this whole thing, we're labeling, this is 2.5 units, 1.5 units from the y-axis, and less than 1.5 units from the x-axis. So I want you to show me the portion of the plane that is less than 2.5 units from the y-axis. So anything that's 2.5 units from the y-axis. So notice there's an overlap right here. All right, so write the coordinates of a point that is in the double shaded part and is closer to the x-axis than line M. So what might you choose? So something that is, so write the coordinate of a point that is in the double shaded part and is also closer to the x-axis than line M. Then line M. So what could be a possible point that you could do? So the x coordinate could be 1.5 or 2.5, and a y coordinate could possibly be 0 or 1/2. So anything here or here would complete that task. So any of these in the double shaded portion that is between 1.5 and 2.5 and is 1/2 between 0 and 1/2 could be 1/4, right? And could be 1/2. 1.5 half, 2.5 half, 2.5 1/4, 1.5 1/4. All right, so we're done with that. So now it's time for problem set. In your problem set, it's simply plotting the points. Name the segment that is perpendicular to the x-axis and y-axis. Here, oh, this is it. You just have it go straight into homework. So that is it for today.